So hello everyone, welcome to the course of signal processing for millimeter wave communication for 5G and beyond. And this is the assignment for week 4. Am I audible? Okay. So let me present the screen first. So I hope my screen is visible right now. So the first question is, consider a random signal xt and that is sine of omega t plus phi varies over time t, where phi follows uniform distribution in 0 to 2 pi, and the mean of the parameter we have to calculate. So what is the answer? Anybody? Okay, let me solve it. So the first question is, there is a signal xt and this is sine of omega t plus phi, and this phi that follows a uniform distribution from 0 to 2 pi. So how I have to calculate the mean? U of x with this is over theta, because theta is the only random variable here. So that is x t over 2 pi. This is the PDF for uniform distribution. 2 pi. And the integration will be over theta, and limit will be 0 to 2 pi. So this can be written like this: 0 to 2 pi and xt is sine of omega t plus phi. Sorry, this should be theta, not phi. Phi, and this will be d phi. So this can be written as sine of omega t cos phi plus cos of omega t sin phi, and the integration is over d phi, and the integration limit is 0 to 2 pi. Similarly, this integration limit will be also 0 to 2 pi, and this is equal to, see, this is the only term dependent on phi, and this is also the term dependent on phi, and the limit is from 0 to 2 pi, and we know sin phi or cos phi, they are periodic with the interval 0 to 2 pi. So the integration, if I do the integration, it will come as 0. If I do the integration here, the term comes 0 from here and from 0 also here. So what is the mean? The mean will be 0. So this is the answer. So okay, so anybody has any question about this question? So the next question is, the autocorrelation of a stationary signal xt is given by rx of r something is 16 e to the power minus 5 tau cos 2 pi r. Let's take this rx of tau, and this is also 8 cos pi tau. I'm like write this thing one second. The question is, we have the autocorrelation function here, and that is rx of tau, and this rx of tau has a dependency on 16 e to the power minus 5 tau cos pi tau plus 8 cos pi tau, and the question they have asked, what is the variance from, we can deduct from of this variable, suppose this is x, what is the variance of x? So what is the answer? Anybody here? Okay, so am I audible? I don't understand, like nobody is answering anything. Hello. Yeah. So anybody to answer this question, like, okay, so nobody to answer this question. So what is variance? The assumption that we had taken in this question is that the mean of the random variable mean of x equal to 0. It was not provided in the question, probably it should have been provided. So how to calculate the variance? It is x square minus expected value of x and its square. So it becomes x square. If we put this condition here, this term will become 0. So what is expected value of x square? This can be written as expected value of x of t plus tau into x of t. What is this? This is the autocorrelation function Rx of tau. Now if we put tau equal to 0, then what does become? Rx of 0 equal to expectation of x squared t. This is the variable we need here. So put tau equal to 0 here. So what is Rx of 0 is 16 plus 8. This terms become 1, this term also becomes 1. 1 for tau equal to 0. This cos term. So this becomes 16 plus 8 equal to 24. This is the right answer of this question. So the right answer is option C, 24. So we come to the third question. The third question is given a WSS process, that is xt, and its autocorrelation is given, that is Rx of k, and also provided that mean is 0, and we have to calculate what is the PST for f equal to 0 here. So let us solve this question. Anybody has solved this question here? What is the answer? Okay, this is the question number 3. This is given that autocorrelation function Rx of k, and this is equal to minus 0.5 mod k, right? So what Wiener-Khinchin theorem says, this says that if I want to calculate the PST, this is the Fourier transform of our autocorrelation function Rx of k. So let us calculate the power of electron density by doing the Fourier transform here. So this is x of omega, and it will be k equal to minus infinite to infinite, and the factor is same, the signal we know. What is the autocorrelation here? 0.5 to the power mod of k, e to the power minus j omega k. So this has two parts, like one part is the k equal to 0 to infinite, another part is to minus infinite. So to calculate this, to omit this modulus part, we divide the function like this. s of x of omega equal to, the first part is k is equal to minus infinite to minus 1, and another part is k equal to 0 to infinite. So in this bracket it will be minus 0.5 mod of k and e to the power minus j omega k. Also here it is the same thing, sorry, this minus is also here, minus 0.5 mod of k e to the power minus j omega k. So let us derive mode. So this becomes, see, this term is negative and this is the modulus. So let us rearrange this, and this will be like k equal to 1 to infinite, and this is minus 0.5 mod of k. So see, mod of k here, what does it means? Like I take any negative number from minus 1 to infinite and it will be like positive, so I can replace it with k, and this k will have a sign change here because I have taken in the limit, summation limit, so it will be e to the power j omega k. This minus and this minus cancels out, plus k equal to 0 to infinite minus 0.5 to the power mod k. This I also can write here like this, like this is only positive integers, so absolute value of k will be like the k actual value, and this will be e to the power minus j omega k. Let me explain why I have divided this like this. What will be the spectrum will come like here. For k equal to 0, it will, what will come? It will come 1. And for k equal to 1, what value will come? Mod of k minus 1 minus 0.5, so minus 0.5 will come here, so this will be minus 0.5, and also for the positive axis it will come minus 0.5, and this will repeat like this, and it will is a converging sequence like this. So Fourier transform exists here. So the thing is, we have divided into two intervals. The first interval is till this, and the second interval we are taking from the 0 point and doing Fourier transform of these two regions. So that is the motto, we have divided it in two intervals. So let me solve it more. So how do I solve after this process? I can write it as, let me write it once more, k equal to 1 to infinite, and now I'm taking this 0.5 factor and e to the power j omega factor, and it is k, plus k equal to 0 to infinite, and this becomes minus 0.5 e to the power minus j omega to the power k. So this is a GP series and this is also a GP series. So what it becomes? It becomes like minus 0.5 e to the power j omega by 1 minus 0.5 e to the power j omega. And also here, this term, these are the GP series formulas. 1 minus 0.5 j omega. This is s of omega. So see, the first term here k is equal to 1, and that is the reason the first term a, what is the formula of GP series? A by 1 minus r. So first term a is a for k is equal to 1, so that is minus 0.5 e to the power j omega. And here what is k? K equal to 0, so it will be 1 here. And the rest of the terms are same, and here is minus is not, because here it is e to the power j omega and here it is e to the power minus j omega. So if I derive for s equal to 0, one plus 0.5 plus 1 by 1 plus 0.5, so this becomes minus 1 by 3, and this is plus 2 by 3. So what is the answer? It is 1 by 3. So 1 by 3 is the answer for the third question. So the option A is the right answer. Now let us come to the fourth question. So the question is like this. There is a discrete time random process representation of channel Hn, and it has a zero mean, and it can be represented at h of n is equal to a of hn minus 1 plus b of wn, where the input process wn is weak sense stationary and Gaussian distributed, and with zero mean and variance sigma w square equal to 3. So the autocorrelation function is given like 4 into 1 by 3 to the power mod of k, and we have to judge what is the value of a and b from the options. Let me write the question once. So what is the question? The question is like this. Gamma h. So we have provided the r of h of k, and that is equal to 4 1 by 3 mod of k, right? This is the equation. So what is the, I declare it as the covariance, autocovariance of the air process here, and if I write gamma 1, then what is this? This is the covariance of h of t, and as it is 1, just an example, h of t minus 1. So if I write it like this, this is covariance of a h t minus 1, as the process has written like this, a of hn minus 1 plus b of wn. So the process is h of n equal to a of h n minus 1 plus b of bw of n, right? So I can derive it like the first thing is b w t. This, sorry, so this n has written, I am taking this as t. Let me take it. The t and n are replaceable here, and this is h of t minus 1. So this is what? This is a into gamma of 0, because This is t minus 1, this is also t minus 1, and this process is independent. So only dependence comes from these terms. So that is the reason it is a of gamma of 0. And what is gamma of 0 here? Like I can say gamma of 0 becomes b square by sigma w square by 1 minus a square, because this is what? This is a covariance of h of t comma h of t, and the only terms that are, because w, this w and h are completely independent, that is the assumption for us. So one term comes from here, and this is covariance of h of t comma t, h of t, right? So that is the reason if we solve this, like it comes, it is gamma of 0, so 1 minus gamma of 0, sorry, 1 minus a square into gamma of 0, we take this term in this side, and this becomes sigma w square. B also is here, and as I calculating the variance, it will be b square. Variance of this term is b square sigma w square. So what is gamma 0 here? B square sigma w square by 1 minus a square. This is the relationship. And right now we have to say now what I had derived earlier, gamma of 1 equal to a to the power a, sorry, this is a, and gamma of 0. Similarly, gamma of 2 equal to a square gamma to 0. So all these equations depends on this gamma 0. So gamma of k will be a to the power k and the factor is gamma of 0. I'm putting the value of gamma of 0 and 1 minus a square. And this is what? This is as given r of h of k. So, and also what is given here? 4 of 1 by 3 or of k. So if we vary the value of k here, these two will, at every instance it will give two different values. And then if we check through the options, here, the results come out as, if we take the value of a is equal to 1 by 3 and b is equal to 32 by 27. These two equations are comparable. So the right answer is this here. So let us go to the next question. I will come to question number 5 at the last. So here, the question number 6. The question number 6 is given the characteristic polynomial of a ARP model of a random process xt is given by phi of b, and this is the multiplication of 1 minus aib, and the process xt cannot be stationary for which of the given choices. So anybody can answer this question? So what is given here? This is a AR model. AR P model and phi of B that is given. Phi of B is the, here B is the, can be written as I is equal to 1 to P into 1 minus alpha IB as sir has taught in the class. So what is the B here? Is the backward operator. So the question is, which of the given values the alpha I can take? So take a simple AR1 model here. For if we can derive it for AR1 model, we can. It is easy to say that. So let me take AR1 model, that is YT, and it is YT minus 1, and there is a factor alpha plus WT. So what is the variance of YT? Is equal to alpha square variance of YT minus 1 plus variance of WT, and so let us take and shift this to the left side here. So what it becomes? 1 minus alpha square into variance of YT equal to variance of WT, right? So now we know what? We know this variance of YT is always 0. Variance cannot take negative values. Variance of WT also cannot take negative values. It is also positive here. So if this side is positive and this side is also positive, what does that mean? This means that 1 minus alpha square, this term should be greater than 0. What does that mean? 1 of mod of 1 of alpha square should be 1 should be greater than 1 of alpha square. So if alpha becomes 2, this does not support. Why it does not support? We have taken that variance of y of t minus 1 equal to variance of y of t. This happens when? This happens when this is WSS process, like variance of y of t minus 1 equal to variance of y of t. So if I take alpha equal to 2, this condition breaks and it suggests this is not a WSS process. Like it is also not a stationary. So what is the answer here? It says xt cannot be stationary. For all other values it is less than equal to 1. So if alpha equal to 2, then the process will not be stationary. So the right answer is option A. Now let us move to the question number 7. So what is given? It is saying that there is a R1 process is given, h of t is equal to 0.75 h of t minus 1 plus wt, where wt is white noise with 0 mean and variance 0.5. What would be a variance of ht? So anybody can answer this question? Okay, let me solve the question for you. This is question number 7. The question number 7 says this is h of t is equal to 0.75 h of t minus 1 plus w of t, right? This is the question given, and what we have to calculate? We have to calculate the variance of ht. So variance of ht is equal to 0.75 square into variance of ht minus 1 plus variance of wt, as to these two processes are independent. So if I take the process as a stationary process, what becomes? This value and this value are same. So I stationary process assumption, if we take the stationary process assumption here, it becomes variance of h of t is equal to 0.75 square variance of ht minus 1, that is also variance of ht, because if I take the stationary process, the variance does not change here, and this is also variance of wt. So what will be the variance of ht? Variance of wt and this is equal to 0.5 by 1 minus 0.75 square, that is 1.1429. So I think the answer given in the question, the options given in the question, that are wrong. Like everybody agrees with me. Anybody is getting any of the options? Okay, I think nobody has solved this question in that case.
Okay, I have not seen the chat. So, Kavita Bhagat has asked to repeat the last step. So, which question can I chat here once more? I have not noticed it.
Okay, so we will discuss it in the last step. If anybody comes here and asks the question again, I will repeat the questions. So the next question is the Hewlett-Walker equation from some air process HT is given by a matrix, and the H equations are given and alpha parameters are also given. So let me clarify this equation. Why this is sort of air model, I am thinking. The question is 8. This is given like this: h of 1, h of 2, h of 3, and what is given? This is 0.5, 0.5 and minus 0.5. Also given like 0.25, 0.25 and minus 0.25, 0, 0, minus 0.125, and the things are given A1, A2, A3. So according to the question, the Euler-Walker equation that is only given for this AR process. So these are the A1, A2, A3 factors, and these are the dependent factors. So how these three things depends? Like, see, it depends on this matrix. Now we have to make the comment how many independent columns are here which are actually spanning this space. That is the main thing here we have to notice, because if there are not three independent columns, then there is no factor of taking all these matrix values, that there's some sort of dependent here, like you cannot span all the spaces. So let us derive what is the rank of this matrix. Depends on the what is the rank of this matrix. You can search this topic in any time series book. So if we try to know what is the rank of this matrix, so see, this becomes minus 0.5, 0.25, 0.25 and minus 0.25 and 0, 0, minus 0.125. So if I do the operation R2 minus R1 into half, so what I'm doing, I'm removing the R1 half from the first row R1 and I'm dividing it by 2, and then I'm subtracting this from the second row. So what will be the entries? So entries, I'm just removing all the entries once again. So the first thing is 0.5, and if I do 0.5 by 2, it becomes 0.25. That is 0.5 by 2 is equal to 0.25, and if I subtract 0.25 to 0.25, it becomes 0. This also becomes 0. This also becomes 0. So what is this matrix? This matrix has rank of 2, not rank of 3. So there are only 2 independent columns. So as there is only 2 independent columns, so what we can comment, this polynomial equation has only 2 roots. Because of 2 independent columns only, and so the process is AR2 process. So the right answer is option B, AR2. Now the next question is, we have given a set of pilot data and received data in a communication system as follows. What are the data are given? So let me solve this question. So what is given here? This is question number 9. X and Y values are given only. The first value x equal to 1, second value is 0.9, and third value is 0.75. The corresponding y value is 1.1, 1 and 0.72. And what is the relation given? Relation is y is equal to alpha plus beta x plus w. So w is the noise term here. So without this noise term, if we think of the least square solution, what will be the approximate value? Y is approximated to alpha plus beta x. We don't know what is the w. So we want to the least square estimation here, as the tabular form is only given. So how do I express the equation? The first equation is y1, y2, y3. And what are the parameters given to me? Alpha is given to me, beta is also given to me. And we have the x values. So first thing is 1 into alpha x1, 1 x2, 1 x3. Because see, if I represent in this matrix format, what it comes? 1 into alpha plus beta into generalized it. Any row you can take, and this becomes this. This is the equation. So I have did the linear representation here. So this is a ranked efficient matrix. So as it is a ranked efficient matrix, how do I find the factor alpha and beta? That is my question. So we have to take the pseudo inverse here. So what is the formula here? I have to take the pseudo inverse of this matrix. Say it is 8. Sorry, take it at x or h, whatever h I can also take h. And if I say this vector as y, this is y. So what is the formula of pseudo inverse? This is h star, where h star is the complex conjugate h whole inverse h star into y. If we solve this equation, like x1, x2, 3, x3, these values are given to me 1, 0.9, 0.75. So, and y1, y2, y3 values are also, like, this is first instance, this is second instance, this is third instance. So if I solve these two equations, just substituting the values, what does the alpha and beta value comes? This alpha and beta, that becomes minus 0.42 and 1.54. So this is the answer here. So correct option is option B. So the last question here. In communication system, which of the following order is more suitable for equalizer design? So let me discuss the question here. So the last question here. I have a receiver and I have a transmitter, and this is receiver. This is transmitter. This is receiver. So what is the first step here? Like, the equation is I receive some data y, and this is depends on the wireless channel h, that symbol that has been transmitted from here, that is x, and that noise that has been added here. So if we get some data y in the receiver, that depends on these three unknown parameters. Now what is our job? From this y, we have to go to x. So to do that, what we need to do first? We need to know h. So what we can do? We can send some x pilot data, and so we forcefully make first step. We make x is known. If x is known, and let us think that w is not present here. W is some sort of error, or its statistics is known only. We can never know what is actual w. So only x is known here right now. So what we can solve? What is the h values? This is the first step. With some x equal to pilot, we know what is the x. In the second step, what do we do? In the second step, we already know h is known now from the first step. As h is known now, and the statistics of w is also known, we can detect the data x. So the process is in the order. We have to do the channel estimation first, and data detection after that. So first is the signal model, second is the channel estimation, and third is the data detection. So there is only one question is remaining there. So I put the last question is question number 5. So the question is, a zero mean random process HT has a PST of S of H of F is equal to del of F plus 2, and it is periodic with periodicity 1. So the process is, so according to me, I know what is the right answer has been given from the regular TS, that is not a mean ergodic process. But however, from my perspective, as I have understood the question, that S of H of F, that is the power spectral density, and it is written that it is periodic with periodicity 1. So this periodicity implies that it is periodic as the PSD is periodic. So this implies only autocorrelation function is discrete. I cannot comment more than that. So, and only zero mean random process is given. I do not know what it is meaning by zero mean. It is time mean or ensemble average or time average in that sense. So according to me, from this data we cannot predict the actual whether it is ergodic or not ergodic. It is very difficult to comment on the whether it is ergodic or not ergodic. Okay, so anybody has any question? You can write in the chat box also. Okay, fine, we'll meet in the next Tuesday. Okay, tell me. Tell me. Yes, I know. Okay, then ninth question, right? That wrong option has been given. Like, let me, these are the given questions, right? Okay, this is the previous year question. This is the previous year question that I'm solving. I'm not solving that, right, for current semester. Okay, 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 okay. Well, I will check. At least give me some time. Okay. Next I will discuss. Like, can you send me the question to me? Like, I have not registered for that course. Oh. Okay, 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 okay. I will acknowledge them about this. Okay, that is fine. Any other query from you? Okay, fifth question, right? Have you solved that fifth question? Like seventh question. Let me go to the seventh question first. So, okay. The seventh question is written here somewhere. So, where is the problem? Like, you have not understood anything, or you are writing down the problem? Yeah. That I told like the option is incorrect, probably. Like from this equation, I can only derive these things. And question number five, I think that is a wrong question. Like, uh, according to options, like you only have PSD, and from PSD you cannot comment on uh, that whether it is ergodic or not ergodic. Like time average and sample average should be same for any ergodic process. So you only have given the PSD, and you have said the PSD is periodic. That PSD is periodic, that means the autocorrelation function can be discrete, nothing more than that, as far as I understand. And also s of h of f is del of f plus 2, and that is also in the interval minus 0.5 to 0.5. So it does not make that much sense from my perspective. So it is only given zero mean random process also, but we cannot comment on ensemble average from our autocorrelation function as far as I know. So you have solved this question, or like I think that option should be cannot be predicted from the given data. But the right answer probably they have put it like not a mean ergodic process. Is it okay with you? Okay. So any more question from anyone? Okay, then we will meet in the next twist. Thank you for participating. Okay, tell me. How are you commenting that? Like, what is the thing? Like you are saying mean ergodic process. How can you say the mean ergodic process? That I want to know. Like, what is the your approach of solving this problem? You have given only the PSD, right? Am I audible? Yeah, that is only that is given, like the PSD has been given. And to prove something that is ergodic, you have to think about time average should be equal to ensemble average, I think. But here I think that is zero mean, in the sense that random process has zero mean in time average. But sample average from PSD, as far as I know, that I cannot comment. Like this is I can derive the autocorrelation function as far as I can go, and from autocorrelation function I can not comment on what is the mean. Like autocorrelation function is e of x of into e of x plus t, x of t plus tau. Even if I take even if I take tau equal to 0, that only gives me expectation value of e of x square, but nothing about e of x. Like I cannot comment on the mean if I have given the PSD. I can comment on the autocorrelation, the second moment from PSD, but I cannot comment on the first moment, I think. Like I have to think about time average equal to sample average, and sample average. Yeah, tell me. Your voice is not audible. It's breaking. Yes, zero mean process in what sense? What you are taking here? Like, yes, zero mean has been given, but zero mean in what sense? It is in the time sense, right? To become ergodic, you have to comment whether it is sample average is equal to time average. The time average is said it is zero, but there is no comment on sample average. Or in the reverse, you can think like sample average. I don't think the question is right, probably. The question should have put more information. However, they have put the question that it is not a mean ergodic process, but still I cannot comment on that also. Is it okay? Okay, then we'll meet in the next Tuesday. Thank you for participating in this meeting.